Okay, we are going to be reading about water in the atmosphere. We're actually going to break this section, which is in the textbook, pages 57 to 60. We're actually going to break it down into two parts. We're going to do water in the atmosphere, the whole section is 54 to 60. And we're going to break it down into two parts. We're going to do pages 54 to 56, which is water in the atmosphere. And then 57 to 60 really covers predominantly clouds. So we are first going to read about water in the atmosphere. And we're going to skip this discovery activity and we're going to jump down here. During a rainstorm, the air feels moist. On a clear, cloudless day, the air may feel dry. As the sun heats the land and oceans, the amount of water in the atmosphere changes. Water is always moving between the atmosphere and Earth's surface. The movement of water between the atmosphere and Earth's surface is called the water cycle. As you can see in figure 13, water vapor enters the air by evaporation from the oceans and other bodies of water. Evaporation is the process by which a water molecule in liquid water escapes into the air as water vapor. Water vapor is also added to the air by living things. Water enters the roots of the plants, rises to the leaves, and is released as water vapor. I want to pause here and talk about this. A lot of times kids think that evaporation and boiling are kind of the same, but boiling is a different process. When you boil it and you see steam, what you're really giving is you're giving those molecules this energy in sort of you're giving them a lot of energy at once, and so a lot of molecules are able to sort of move from the liquid to the gas phase and into the air. But evaporation is sort of a natural process where just really the molecules at the surface are gaining enough energy, and then they can go from the liquid into the gas into the atmosphere. Water can evaporate from living things. It said it can evaporate from our skin, and when you sweat in the summer and that water that sweat evaporates off of your skin, that's what's happening. Is water can move from the land, from plants, from living things into the atmosphere. But it's not like when you boil and it produces steam. It's a much slower process, and a lot less molecules move during that process in one small area. It says, as part of the water cycle, some of the water vapor in the atmosphere condenses to form clouds. And we've all seen clouds in the sky, of course. And then from those clouds, you might get rain and snow that fall from the clouds towards the surface. The water then runs off the surface or moves to the ground, back into the lake streams, and eventually the ocean. So we're talking about the water cycle here, which you may have studied before. So water evaporates from the surface of the earth or from the living things on the earth. And then when it's in the air, it rises. And when it gets higher in the atmosphere, we know the temperature drops. And so the water molecules will cool and they will condense and they will form droplets and clouds, which will then, and that's condensation. And then when those those droplets get big enough and heavy enough, they fall from the sky as precipitation. And we'll be talking about the different parts of the water cycle here. So, humidity, it says. Humidity. How is the quantity, or the quantity means the volume or how much, how is the quantity of water vapor in the atmosphere measured? Humidity is a measure of the amount of water vapor in the air. Air's ability to hold water vapor depends on its temperature. Warm air can hold more water vapor than cool air. And this is going to be a little bit tricky to understand, but we have talked about in the past how when things are colder, when you cool a fluid, when you cool a gas or you cool a liquid, you take energy from those molecules move less, and so they condense. And then when they are heated up, they have more energy and they spread out and they expand. Well, this relates to humidity because in cooler weather, when those air molecules are sort of condensed and closer together, there's not as much room in there to hold water molecules. So colder air cannot hold as much liquid. Warmer air, the molecules are further apart, they've expanded, so there's more space in between the air molecules in warm air to hold more water vapor. And when we measure humidity, it is given at a specific temperature because it's given at a percentage. And since cold air can hold less water vapor, its percentage would not be equal to the same amount of water that it would be at a warmer temperature. And I know that sounds confusing. We're going to talk about that. Relative humidity is what I've been talking about, really. Weather reports usually refer to the water vapor in the air as relative humidity. Relative humidity is the percentage of water vapor that is actually in the air compared to the maximum amount of water vapor the air can hold at a particular temperature. It's a mouthful, but let's talk about that. It says, for example, at 10 degrees Celsius, 1 cubic meter, so a box that is 1 meter wide and 1 meter long and 1 meter high, 1 cubic meter of air can hold 8 grams of water vapor. Now, if there were actually 8 grams of water vapor in the air, then the relative humidity of the air would be 100%. Air with the relative humidity of 100% is said to be saturated, meaning it cannot hold any more water. If the air only had 4 grams of water, but it could hold 8, the relative humidity would be half or 50%. And we're going to talk about what that means. And again, here's that picture of the water cycle that we talked about where the water is evaporating from lakes, ponds, oceans, streams, living things. As it gets into the atmosphere, it cools, forms droplets, and that's called condensation. Those droplets get heavy enough and it precipitates or it forms precipitation, rain, sleet, snow, and hail. And then that water will run back off into the streams that the water cycle feeds, and we'll start all over again. But talking again about humidity, it says measuring relative humidity. This little random tool looks a little silly. We're going to use something like that, but that looks like a really old one. Measuring relative humidity. Relative humidity can be measured with an instrument called a psychrometer. We're going to use that. It's called a sling psychrometer. A psychrometer has 2 thermometers, a wet bulb thermometer and a dry bulb thermometer, as shown in figure 14. The bulb of the wet bulb thermometer has a cloth covering that is moistened with water. When the psychrometer is slung or you spin it by its handle, air blows over both thermometers. Because the wet bulb thermometer will then be cooled by evaporation, its reading drops below that of the dry bulb thermometer. We will be using sling psychrometers in our relative humidity lab, and we will explain how all of that works. If the relative humidity is high, the water on the wet bulb evaporates more slowly and the wet bulb temperature doesn't change. But if the relative humidity is low, that water that's in that little wet cloth will be able to evaporate and cause more cooling. So if the relative humidity is low, the water on the wet bulb evaporates rapidly and the wet bulb temperature drops. The relative humidity can be found by comparing the temperatures of the wet bulb and dry bulb thermometers. And so let me talk about that with you here. So you'll see this analyzing data form, and it gives us some problems. It says, relative humidity is affected by temperature. Use the data table to answer the questions below. The first thing you'll do is you're going to have 2 temperatures. You're going to first take your dry bulb temperature, and it's going to tell us that in the problem. And then what we're going to do is we'll have a dry bulb and a wet bulb, and they're sort of placed next to each other. The wet bulb is basically that thermometer that has the wet cloth over it. And you put the wet bulb and the dry bulb on this little stick, basically, and then you spin the stick, and the 2 thermometers spin in the air. Now, the dry bulb, the temperature is not going to change because it's going to stay the same temperature of the air. But the one that has the little wet piece of fabric on it, that wet fabric, some of that liquid in there is going to evaporate. That takes energy. So that energy is going to come from really the thermometer, and the thermometer is, those molecules are going to give energy to the water molecules on the cloth to evaporate. So then those molecules in the thermometer will have less energy. The thermometer molecules will condense, and the temperature actually comes down on the thermometer, and you'll get a cooler temperature on your wet bulb. And so this says, first you're going to find the dry bulb temperature in the column, and then you're going to find the difference between the wet and the dry bulb, and then you'll find the relative humidity. So I'll walk you through a problem. It says at noon, the reading on a sling psychrometer is 18 for the dry bulb and 14 for the wet bulb. What is the relative humidity? Well, first of all, we have to find the dry bulb temperature, which we said was 18. The difference between 18 and 14 is 4. So if the dry bulb was 18 and the difference was 4, the relative humidity would be 64%. And I'm only going to do that problem because, again, like I said, we're going to be practicing some more. That's it for this section. You'll have pages 57 to 60 in another reading. I hope this makes a little bit of sense, but don't worry. We will be doing some activities that will help clarify it.